Hello and welcome to Challenge Accepted, the podcast that explores comprehensive engineering solutions for complex projects. In each season, we dive into a different project sector with a panel of experts discussing how they've tackled their industry's most complex challenges. This season, we're diving into PFAS, exploring the evolving regulations and how we're helping clients navigate this complex and rapidly changing landscape. Hi, my name is Adam Hackenberg, and I am your host for this season of Challenge Accepted. I am a senior project manager in Langen's Philadelphia office and one of the leaders of our firm's PFAS practice. Today, we're going to be talking about the transition away from firefighting foams known as AFFF or aqueous film-forming foams and towards firefighting foams that do not contain intentionally added PFAS. Now, firefighting foams have been around since the early 1900s. And while early foams were composed of relatively benign salts and plant-based materials, by the 1960s, a series of innovations led to the development of high-performance firefighting foams containing fluorochemicals, including a type of foam known as AFFF, or, as I mentioned earlier, aqueous film-forming foam. Over the years, awareness has grown regarding potential environmental and health concerns associated with the family of fluorochemicals used in these foams, which are known as PFAS, or per and polyfluoroalkyl substances. Based on these concerns, there has been a move away from fluorochemical foams, including AFFF, and a move towards firefighting agents that do not contain intentionally added PFAS. So joining me today to talk about their experiences helping clients transition away from AFFF are three Langen environmental professionals, Dan Bosworth, Courtney Savage, and Grayson Basiliga. Dan is a senior engineer based in Parsippany, New Jersey, and a national leader in Langen's airport and aviation practice. Courtney is a certified hazardous materials manager based in Philadelphia, Pennsylvania. And Grayson is an environmental scientist also based in Pennsylvania. So, Courtney, I'd like you to start us out by maybe explaining why fluorinated foams, including AFFF, have come into such widespread use and a little bit about the types of facilities where they're used.
Absolutely. So there's a reason AFFF was used. It's really good at what it does. It was the go-to weapon for extinguishing Class B liquid fuel fires. So it was commonly used and even required in a lot of instances at facilities that handle large quantities of fuel, like your airports and heliports, aircraft hangars, because of the jet fuel. Part 139 certified airports are required to use foams that meet military specifications, which was essentially AFFF until 2023, because the DoD, the Department of Defense, didn't publish a military specification for fluorine-free foam, or F3, until January 2023. There's over 500 Part 139 certified airports in the U.S., so that is a concern for airports. And then oil and gas facilities like refineries, fuel storage farms, pipeline distribution facilities, they were required to maintain AFFF by the National Fire Protection Association, or NFPA. Also military bases, DoD sites, which commonly use AFFF systems for training, vehicle and aircraft fire protection and general fire suppression, chemical manufacturing plants, municipal fire stations and fire training facilities, and then really any industrial facility or warehouse that stores flammable liquids that could have a fixed foam system that automatically releases AFFF when a fire is detected.
It sounds like there are a lot of different kinds of facilities that may have these AFFF systems. I'm just wondering, are they all the same? Are there variations between the systems that are installed at these different facilities? I'm wanting to sort of create a mental image for our audience here. What are we actually talking about when we're talking about AFFF systems? Dan, maybe you can get us started off with that.
Yeah, sure, Adam. So when you look at the fire suppression systems, you really have two primary types and that are considered, and those are really going to be your fixed systems and your mobile portable systems. So we're going to start with the fixed systems because that pretty much dovetails into the facilities that Courtney was speaking of. So these are really more of your permanent fire suppression systems that you see inside of the hangars, your maintenance shops, and the other facilities that Courtney had mentioned. And they really can cover the entire interior of the facility. But you can also have portions where maybe you have a staging area for dangerous goods or other hazardous materials that may require fire protection system. We'll just cover that small area. But these fixed systems essentially act as almost an automated fire extinguisher to, protect those high-risk areas. Now, you generally have a few key components. So to maybe try to help the audience visualize what this looks like, maybe let's start with most people know. And that's typically your overhead distribution piping network, with the sprinkler heads. So I think most people have likely seen this. When you're inside a facility, you look up toward the ceiling, you see the fire suppression system piping, you have the sprinkler heads, and those are typically connected to the joists and beams along the ceiling. Now, for you to trace that piping network back to its origin, this is where you see some of the other components. You generally have the AFFF concentrate tank. So this is where you store the AFFF. And inside that tank, you actually have a bladder. So the bladder pretty much contains your AFFF. And then when it's discharged, that bladder actually compresses and condenses, and that will release your concentrate. With that tank, you have your water supply system, that's coming into the building. And then you have a series of control valves and pumps, which, essentially isolate the system. And then upon activation, we'll pump the liquids. The other key component, you have a proportioner. So this is really used to mix the concentrate in the water, and it's usually at a specific ratio, anywhere from 1% to 3% foam solution. So when you kind of look at the system as an overall whole, you have your sprinkler heads. These are typically triggered, whether it's through smoke or heat. That's going to trigger the system. The AFFF concentrate then gets released, and it's ultimately mixed with the water through the proportioner, and then it's distributed to that piping network, and then discharged to address the fire. I did want to highlight you have a couple types of systems. The primary ones are a wet system and a dry system. So the wet system is where you actually already have the system charged. It's filled with your liquids. So when it's triggered, it actually has immediate release right at those heads. And then you can also have a dry system where there's no liquids within the pump. And then, you need the system to get triggered and activated for that to be released and, discharged through the piping. So, those are pretty much the high level components of the fixed system. Now, on the other side of the coin, you kind of have your mobile systems. That's really the boots on the ground, the fire trucks and rescue vehicles being brought, and they're actually being brought to the facilities to extinguish the fire. I know we love our acronyms. So another one we'll define is the airport rescue and firefighting vehicles. We're going to call them ARFs. But those are the other components, like I said, where you actually see the vehicles being brought to the facilities to extinguish them. Grayson, you're really our ARF expert. Maybe I'll kick this over to you to highlight some of the components of those ARF vehicles.
Yeah, ARF systems at their basics are pretty much the same as the fixed system. They're going to have their bladders, they're going to have their water storage and the piping that leads to the nozzles. The primary difference is that this is a much more compact and sealed container, aka a vehicle. And instead of having multiple different sprinkler nozzles throughout like a warehouse or a hangar, you typically have a turret or two on the front of one of these ARF vehicles. It makes testing and the functionality of this much more mobile, but also more complicated when it comes to any sort of maintenance or work to be done on these vehicles, just because of the sealed nature of them.
Thanks, Grayson. So we've learned a little bit now about some of the environmental concerns or potential environmental concerns that are driving the push to move away from AFFF systems. And we've learned a little bit about what these systems look like and the types of facilities where they're used. I want to get now into a little bit more about beyond sort of these potential environmental and health concerns. Can we be more specific on what is driving companies to make this transition? I'm thinking more from maybe a regulatory or business driver perspective. Courtney, I know that that's an area of your expertise. Can you start maybe by walking us through what kinds of regulation and guidance we're seeing from the federal government on this?
Absolutely, Adam. Overall, we're in a transitioning period. That's the big takeaway. At the federal level, the charge is being led by the U.S. Department of Defense and the Federal Aviation Administration, DoD and FAA. Again, think back to where we're seeing these systems. It's airports and military bases are two of the primary facility types, and in collaboration with the U.S. Environmental Protection Agency, or EPA. And FAA and DoD, they engaged in a joint research project to test the F3, the fluorine-free foam. And they developed an F3 transition plan that is supported by EPA. FAA relies heavily on DoD policies. They often put out CERT alerts that have DoD memoranda attached for guidance. They rely on military specifications for foam and the qualified products list, which is qualified products that meet military specs. Right now, there are 6 F3 foam products on the QPL that meet the mil spec for F3. So those foams are able to be used at Part 139 airports in accordance with FAA policy and regulations. However, at this time, there are no FAA requirements for airports to transition to F3 foam. It is encouraged, but not required. And then in August 2025, semi-recently, the DoD extended its deadline to end the use of AFFF by 1 year to October 1st, 2026. So at this point, AFFF is still being used. Transition to F3 is encouraged, but it is not required for airports at this time. And DoD has an extension through about 1 year from now.
Interesting. I wonder if the situation is different at the state level, though. Are there states that are sort of ahead of the federal government in terms of how they're addressing the ability of these types of facilities to continue using the PFAS containing foams?
Absolutely. There are regulations on the state level, and they're in all different sorts of passage legislature, depending on what state you're in. Many states, you're typically starting with a ban on discharging AFFF for training purposes or any purposes other than emergency response. So basically, if it's absolutely necessary, kind of the next stage or the next legislature you're starting to see is banning the manufacture and then eventually the distribution of AFFF. So, for instance, in Pennsylvania, House Bill 1261 was passed by the House in July 2025. It's currently in the Senate. And this bill, and many like it, would ban manufacture, sale, or distribution of AFFF by July 1st, 2026. And then 6 months later, by 1/1/27, it would ban anyone from discharging AFFF. So it's coming, and in some states sooner than others. And getting ahead of the transition is definitely recommended and smart because there's probably going to be a run on the F3 foam with potential supply issues. And likewise, companies that specialize in transitioning systems, the mechanical aspect of it, the consulting aspect of it, they're going to be scheduled out. So the longer you wait for the transition service, the supplies are going to get more expensive. You're going to have longer wait times. No one wants to be stuck with a non-compliant suppression system. It could cause the need for fire watch. It could disrupt operations. So getting ahead of the game is really smart at this point.
Yeah, I'm glad you said that, Courtney. I was going to ask you if there was a challenge getting these older foams, given that there are so many state-based bans that are starting to take effect now. And it sounds like what you're saying is that, yes, indeed, it may get harder and harder to not only find the old foam, but to replace it with new foam, as lots of people are sort of doing this all at the same time. So I think the next thing that we want to talk about here is the thrust of today's conversation, which is if you are an entity who has one of these systems, whether it's a fixed system or whether it's a mobile system like an ARFF vehicle, firefighting truck that's got foam, want to understand and share with the audience a little bit about the process, what it takes to decommission one of these old systems, what are the steps to take, and who are the key players involved in this. I'm imagining that this isn't something that a single company comes in and does, but you need a complement of different types of services to support these activities. So Dan, I know you have some expertise in this area, and you've helped with AFFF system transitions at a number of facilities, particularly fixed systems. So what can you tell us about that?
Yeah, it's a good question, Adam. So it really comes down to ready to start at the front of the project, and that's when the critical decisions need to be made. And the $1,000,000 question that everyone's really asking and everyone wants to know is how clean is clean? So let's just say you're going to flush, clean, and reuse an existing system. There are currently really no requirements to establish the levels you need to clean the system down to. So you really need to look at each facility on a case-by-case basis, evaluate those specific criteria for your facility. And, at the end of the day, if you do have residual AFFF in the system and it's going to be discharged, what are your potential risk and liabilities? Can that material get into the subsurface soils? Can it get into catch basins? Do you have sensitive receptors adjacent to your facility, maybe water bodies or schools or daycare facilities? So those are really the factors that you need to look at right up front and really establish your risk tolerances and ultimately develop that plan for how you want to address the facility. Now, you kind of mentioned a little bit the parties that are going to get involved. This is typically where you might have an environmental representative, the consultant come in. They can kind of help work with your risk team, figure out what factors, what levels you want to achieve, and ultimately how to get down to them. You're also going to have some other players. You're going to have your fire suppression engineers that are going to look at the systems. Can you do a direct replacement where you're taking that F3 foam, maybe getting rid of the concentrate and replacing with an F3? Or do you have to do some system modifications or update the system? And then you're also going to have your contractors, your material management team that's going to come in. They'll actually be boots on the ground. They'll do the flushing, assist with the cleaning of the components, and then ultimately handle the disposal of material. That's really the most important component, making sure whatever process you're going to go through that you're handling that material accordingly, and then, disposing of it and getting the final manifest at the end of the day.
Thanks a lot, Dan. It sounds like this is a pretty complex process, and I'm just wondering, as a quick follow-up, generally speaking, how long does it take to go through one of these transitions? And what do you do while that's taking place to ensure that there is ongoing fire protection at these facilities?
That's a great question. And it's a little bit of a complicated answer because it really depends on what you're going to do to address the system. So, if we maybe break this down, each alternative is one component be maybe replace the entire system. So if you do have some concerns with residual PFAS or AFFF, maybe you have some of those sensitive receptors. That one option would be to replace the entire system. Now, obviously, this has some pros and cons. The positives, you're really eliminating the AFFF from the equation and ultimately reducing your overall risk and exposure. And when you do these system replacements, to your point, you have this downtime, right, where you're going to need fire watch while the system's being updated. You may have to suspend your facility operation. So there may be instances where you can theoretically keep the existing system in place and maybe install your new system concurrently. So, this might eliminate the need for fire watch, suspending your operations. But at the end of the day, you're going to need a structural engineer to kind of take a look at that and see, if the existing infrastructure could support the loading of the two systems. So that's one alternative. Now, the negatives with your replacing entire system are going to come down to cost. If you're exposing the entire piping network, you're going to have to cut the system into small pieces, 18 to 18-inch by pieces. You're going to have to dispose of material. Now, I don't want to get too far into the pricing realm, but this is going to be order of magnitude of a couple $100,000 just for disposal. So there's all these factors that need to be considered. If you're doing a full replacement, that might be on the order of magnitude of months. But again, if you're tying in some of this where you can keep the existing system in place, maybe that's less of the evil with downtime and having fire watch in place. So that's kind of just looking at the replacement option. Now, if you were to do a flushing and removal of the AFFF, that's generally, I'd say, anywhere from 3 to 4 weeks. But before I dive down that rabbit hole, I don't know if we wanted to stop there and if anyone had any comments on the replacement of the system.
Well, I want to give Grayson a chance to chime in here on his experience with doing these types of changeouts for mobile systems. So, Grace, I'm wondering, is the process that Dan just described for fixed systems, do we go through a similar process for the mobile systems, or are there special things that make the mobile system change outs a little bit more distinctive?
With the mobile systems, the ARFS vehicles, they typically, you cannot go through a full system replacement as Dan described just now. You're not going to be able to get into all the piping and fittings that were designed by the manufacturers and set in very easily. And so really the only route you can go with these ARC vehicles at this moment is either completely removing them from commission and having them not be vehicles that support firefighting anymore, or going down the decontamination route and determining how clean is clean and performing tests to ensure that you have the proper ratios and decontamination within the system prior to having it be ready for F3 use.
So, Grayson and Dan, you both asked the question, how clean is clean? And I think a lot of people are wanting to know more about this. And I'm wondering if you can expand on that. I know, Dan, you said there's not really an industry standard for it, but are there levels of reduction that can be reasonably achieved? And what are some of the strategies that are being used to achieve those levels of reduction when we're doing a clean out of a fixed system or a clean out of a fire truck or something like that?
That's a great question. It's kind of on the other side of the coin now, where instead of doing the full replacement, it's can we flush and clean that existing system and get that down to a level that, everyone's happy with. So again, there's really no established guidelines for that, but generally what we've been seeing, we'll call it the industry practices. We've generally been seeing where you'll do a 3 flush rinse of the system. So you'll remove the AFFF concentrate. You'll actually do a flushing of the existing piping network. So you'll do a 3 flush rinse. Now, typically it's done with hot water. You can certainly use other proprietary chemicals such as perfluoride and some other chemicals, but really the goal is to flush it and to get those levels down. And a good guideline is to get your total PFAS concentrations down to below 1 part per billion for your total concentration. Now, we've generally been able to achieve that on most of the projects we've done the 3 flush rinse with. And what kind of to track that to what you're alluding to, Adam, is what you can actually do is after you do each flushing cycle, you can actually collect samples and analyze that effluent for, your PFAS parameters. So you can actually get that live data. Hopefully you're showing those reducing trends and those reducing concentrations. And then when you get to the endpoint, what you have left in the system, you can then make that determination, or, have we achieved the levels we're looking for, or do we need to do, additional flushing and rinsing to get it down to, an acceptable level. So long story short, I think the general guideline is, your total PFAS below 1 ppb. But again, that's open to discussion based on your facility and, what the overall risk tolerances are at the end of the day.
You mentioned ppb or parts per billion level. Can you just give the audience some points of reference as to what does that mean from a practical perspective?
when you think of ppb, it's really parts per billion. And for comparison, one ppb, it's equivalent to one drop of water in a 10,000 gallon swimming pool. And it seems like a very small volume, but then when you actually take a larger step back, when you do the PFAS testing, they actually measure the PFAS concentrations in parts per trillion. So that's even smaller than that, where you're talking, that's the equivalent of one drop in 20 size Olympic swimming pools. So to even do that testing, they have very specialized lab equipment to get down to those concentrations. So like I said, you're generally measuring the individual constituents in the parts per trillion. And then when it rolls up, you're looking to get that total PFAS concentration of those parameters under that 1 part per billion mark.
And it seems like the general idea here is to make sure that we're not leaving your residuals in the system such that if the system does go off or trigger in the future, you want to make sure that you're not going to end up with old foam residuals that are still present in the system and continuing to come out when the system is activated going forward and causing potential environmental concerns.
One of the reasons that like Dan's saying 1 part per billion and not trying to achieve zero is one, laboratory cannot prove that we have gotten a true zero reading with PFAS right now. But the F3 foams as well that we are replacing AFFF with, a lot of them do contain up to about 1 part per billion as a maximum concentration of byproduct of PFAS within their foams. That's what they're allowing currently. So even if you have a perfectly decontaminated system, you're still going to have, with the new foam, a potential for PFAS to exist within that system, just at a much lower concentration than it would be at AFFF.
Yeah, thank you for that, Grayson. And for folks who may be wondering, like you may be listening to this and thinking, Dan's saying a part per billion. That seems really low, right? But something to consider is that the regulatory levels that are being implemented, both at the federal level and in some states, are equally low. We are talking about concentrations, to clean up concentrations and targets that are within that range, parts per billion, parts per trillion, and below. So I know it doesn't sound like a lot, but those are levels that still could potentially be of concern from a regulatory perspective. And speaking about regulatory concerns, I want to transition now to talking about all of the materials that are going to be generated when you dismantle and decommission an old system. So we're going to have the old foam itself that's going to be removed from the system during the decommissioning process. Dan was talking about cutting piping up into 18-inch sections. There is going to be potentially old tankage and tank bladders and nozzles and proportions and all sorts of things that you may need to dispose of in connection with one of these decommissioning projects. So I want to tap here into our resident certified hazardous materials manager, Courtney, to talk to us a little bit about how are these materials viewed from a waste management perspective? Are there rules that would guide us in making disposal decisions with this material? I guess let's start off with that.
Absolutely. There are. It's a big question right now. And there is a question, is AFFF and PFAS impacted material considered hazardous waste or not? And it is a question because there's incongruity between the two federal acts known as CERCLA, which is like the Superfund Act or the Superfund Law, and then RCRA, which is the Cradle to Grave Act or the Responsible Waste Management Act. Currently, PFOA and PFOS are listed as CERCLA hazardous substances as of July 2024. The EPA essentially has jurisdiction for cost recovery, enforcement actions related to releases of PFAS. There's release reporting implications associated with listing PFOA and PFOS as CERCLA hazardous substances. However, there are no PFAS listed as RCRA hazardous constituents under the RCRA Act currently. EPA did propose to add 9 PFAS to the RCRA hazardous constituent list in February 2024, but that rule has not yet been finalized. It's still pending. And listing as a RCRA hazardous constituent is a building block for any future work to regulate PFAS as a RCRA listed hazardous waste. So that being said, even though technically it's not a hazardous waste, EPA does recommend disposal at a Subtitle C hazardous waste landfill because of the engineering controls associated with that and the protection for potential migration of PFAS.
So that's a recommendation from EPA, but not a requirement. I mean, I'm wondering if you can comment on sort of the decision-making process that a company might go through in determining how to handle their waste. It sounds like it's really an internal risk management decision-making process. Is that a fair characterization?
That's exactly what it is. It's liability, risk management, decision making at this point.
Maybe you can just briefly mention beyond landfilling, whether it's at a subtitle C, hazardous waste landfill, or another kind of landfill. Are there other options that EPA or others have put out there for disposing of this type of waste?
Yes, EPA has put out a guidance document in 2024 with recommended PFAS management for disposal options. And those options do include like closed loop landfills. And they recommend subtitle C landfills. Specifically, they say when PFAS levels of the waste are relatively high, but that does not have a definition or a magnitude attached to that kind of subjective phrase of relatively high. So landfilling and then high temperature incineration. There's been some concern about this method because of the potential for incomplete combustion byproducts during incineration. And we're talking high temps, we're talking around 2000 degrees Fahrenheit, so very high temperatures. Recently, a study published by Veolia in May 2025 did indicate effective destruction of over 99% of PFAS at their Texas facility. So that came out relatively recently. And I think there's starting to be increased comfortability with the HTI or high temperature incineration destruction method for PFAS impacted waste. DOD did issue a temporary moratorium on incineration in 2024, and that's in effect still. And there's an ongoing federal study on PFAS destruction via high temp incineration. So there's research projects being done. There have been some industry studies, like I mentioned, the Veolia one, that do indicate effective destruction of PFAS at very high temperatures. And there are facilities, mostly Clean Harbors kind of has the most facilities with these high temp incineration capabilities. There's one in Utah, Texas, and I believe Arkansas, and then one or two in Canada, I believe. They're out there, but they're not everywhere.
Yeah, so it's an option, but an option that's maybe a little bit limited now. There's ongoing research. I mean, I've heard people talk about the idea of destruction of efficiency of, you may have heard like 6 nines or 99.999% treatment efficiency. But it's potentially a very good option, but research is ongoing and there just aren't that many facilities. So I'll just mention one other that's out there that I think it's referenced in the same EPA document that you mentioned, Courtney, and that's deep well injection. So I know that some of our clients are using that as an alternative for disposing of liquid waste. I mean, this isn't something that you would apply for solid waste for sure, but deep well injection is being used for disposal of AFFF concentrate by a number of clients and folks in the industry. But like incineration, deep well injection is sort of limited in its availability. There, as far as I understand it, there are just a handful of facilities that are out there that actually market this as a service.
That's right, Adam. It's essentially sequestration of the PFAS waste, and we're talking like 5 to 10,000 feet, so almost 1 to 2 miles deep below impermeable rock, where it's separated from entering any potential underground sources of drinking water. Like you said, it is limited as far as where these deep well injection sites are. I know there's one in Texas, but that's really the only one I'm aware of.
We've gone through the whole process here. We've gone from where are these systems located? What do they look like? What are the components? We've talked about fixed and mobile systems. Who needs to be involved when we're going through a decommissioning project? And what do you do with the waste? And I think all three of you have been integral in helping clients navigate this process. And I'm imagining that there have been some lessons learned that have come out of your work on these types of projects. So I'm wanting at this point to know if you all can share maybe with the audience some of the lessons learned about how to navigate a project if you're contemplating getting rid of your AFFF system and moving to something new. Are there some pro tips you can offer? And let's start, Dan, maybe with you.
Yeah, I'll go first because I think my biggest recommendation would be, again, kind of going back to what we spoke about earlier, the early stages of the project is really getting in front of the issue with the fire suppression in the system to where you really need to sit down, you need to bring the right team in, and it's really understanding what the goal is at the end of the day for your facility, understanding what those risk tolerances are and really figuring out where you want to get that system to the end goal. That's really the most critical part. The field work is actually, I don't want to say the easy part, but making sure you have that plan, you get the work plans in place, you can put together the scope of work documents, the bidding documents, and ultimately get those out to the team just so everyone, you can kind of lay out that roadmap. And that's really going to ultimately help you successfully deliver the project. And it's really bringing in the right team members, bringing in the team that understands, what your goals are, how to get those levels down to where you want to achieve them. And then ultimately, when it comes to handling and managing the waste, that you have the right team in place to control that, and that you're going to get the appropriate management and handling of that, and then with the final manifest at the end of the day. So I think that initial coordination up front and making sure you lay out that roadmap, that's probably the most critical part of the project.
Does that planning process, Dan, include making contingencies for things that could go wrong? What if there's a release of AFFF or some spillage out of a pipe or something like that? Are those examples of things that can go wrong? Do you have other examples of things that could go wrong in the process? And are those key elements of the planning process up front?
Yeah, absolutely. And maybe I'll give you two examples where they show both ends of that, to where if you have those systems in place where you understand what the goal is, working with the contractors, it's almost at the start of the project, you want to set the expectation that the goal is not one drop of this AFFF can touch the ground. You need to have the plans for your secondary containment units, how you're going to manage that material, how you're going to do the flushing operations, and really get that outlined so everybody's on the same page. And then when you have that in place, obviously, you can, exactly to your point, Adam, you can have your contingencies, you have your backup plans of where, hey, if we do have a release, this is how we're going to contain it and control it. But if you kind of do that planning up front, you hopefully alleviate a lot of those concerns, and you generally have less issues when you implement the field work. Now, I've seen on the other side of things where it was maybe you don't have that coordination up front. It's kind of like, oh, we're just going to do it, bring in the contractor. If they don't have that secondary containment in place, they don't understand how they're going to handle the materials. And I think this was a great lesson learned, to where on one of the projects, we were able to support with the bid sheets, and we outlined a plan that, hey, we're getting rid of this tank. It's going to be handled as AFFF impacted material. A lot of the contractors might be under the assumption that, hey, we're going to take this tank and we're going to scrap it as steel. If the bladder inside it is intact, we're just going to take it to a scrap yard. And obviously, as the owner generator, if you're putting on that hat, there's no way you would probably want anything with AFFF in the name going to a steel scrap yard from a liability side. So, and obviously that was a huge change in pricing. I think assuming you were scrapping it versus taking it out as AFFF impacted, you're talking order of magnitude, $250,000. So again, going back to making sure you have all this laid out, you have the roadmap, and you have the right players. That's really the most important component.
Yeah, fantastic. Grayson, wondering about your thoughts on all of this. You agree with what Dan's saying? Do you have any additional pro tips to contribute to the conversation?
My biggest takeaway is try not to tackle this yourself. Even here with all the resources we have at Langen, we team up with multiple different companies in order to do things like the decontamination, the waste management, even things like output testing for our vehicles. We have contractors. There's a pretty overwhelming process, and there's a lot of moving parts. So make sure that you're identifying the right folks to talk to about this, who have the experience, who, like Dan was pointing out, there's a lot of risk and liability into things, who have the experience and have seen firsthand instances where we always talk about a risk is something that probably won't happen. But if it does happen, have folks who understand what the next steps are to make it right and make it continue forwards.
All right. Thank you, Grayson. And Courtney, maybe you can bring us across the finish line here, thinking not only about tips for implementing one of these projects, but looking into the crystal ball. What can companies who need to do this or want to do this, what can they expect going forward as more and more of their peers are also wanting to move forward with a similar process?
Sure thing. Get ahead of the regulations. They're coming. Don't get backed into a corner. We talked about earlier, there's going to be a run on supplies and services in this market. So plan early, start now if you haven't got started yet, and assemble a knowledgeable team, lean on experts, like Grayson and Dan both said. Also, waste disposal is typically an end of the project consideration and an afterthought, but for this particular type of project, it shouldn't be. It needs to be discussed early and incorporated into the plans before boots hit the ground for sure, because there are a lot of considerations there.
Fantastic. Thank you, Courtney. And thank you, Dan and Grayson. It's been fantastic hearing from the three of you today. I hope our audience has gotten a lot of useful information and tips out of this conversation, and we really appreciate you being here. So thanks, everyone. That is it for today, and also for the first season of Challenge Accepted. Thanks for listening to Challenge Accepted, PFAS. If you like what you heard, please like, subscribe, and write a review on Apple, Spotify, or wherever you get your podcasts. For more information, check us out on LinkedIn and Instagram at Langen, E-N-G-E-N-V, or visit langen.com/PFAS. See you next time.
This podcast was edited by Resonate Recordings.